Hi guys, good afternoon everyone. Good afternoon guys. How are you all? I hope everyone is doing well. So what we'll be doing today is we'll be discussing about ionic product of water, and it's a small topic but yet important topic to understand many of the things regarding water. So we'll be discussing about it, and all of you know that water is very important for us, right? It is really important for all of us. So it has very unique properties like which we have studied even in our lower classes as well. But when we'll be discussing ionic product of water, we'll be understanding even one more unique property of water, which you guys will be amazed to know. And yes, we'll be discussing that. So before starting with the topic, guys, let me just quickly introduce myself because the new students on the platform, they will be curious to know about me. So I am Manisha Rani, guys, chemistry educator at Unacademy. I have enriched 5 years of experience for online and offline teaching. And I have done my master's from NIT Warangal and bachelor's from Delhi University. I have cracked IIT JAM, CSIR NET and GATE. I have given best ranks to my students, and also yes, I'm a plus verified tutor, guys. So talking about myself, I hope now you guys know me better. And now let's just start with the topic only, that how we can relate what is ionic product of water, and what is little thing which is like special about this. So let's just quickly discuss about it. So talking about ionic product of water, guys, what you can relate, a simple thing, water. Water is an important substance. So all of you know that what is the nature of water. Yes, everyone knows it. The nature of water is neutral. But still, if I'll say that water reacts with acid as well as base in spite of being neutral. Now, how and why? Let's just discuss that. So, talking about the first thing, that water acts as a like it's neutral, but it reacts with acid as well as base. What is the reason for it? So the reason is because for water in general, guys, the pH which we remember is 7, right? But actually the pH of water is found to be in between a range like 6.9 to 7.1. Okay, and when you take the average of it, so if you will take the average 6.9 plus 7.1 divided by 2, you get 7 as a pH, which we consider as neutral. But water can act as both, like slightly acidic as well as slightly basic. Okay, now talking about the dissociation constant of water and like ionic product of water, what we can relate over here is a simple thing, that water whenever dissociates, if you will see here, if water will dissociate into ions, what it is going to give? It is going to give H plus and OH minus ion. H plus and OH minus ion, you can relate that acids are the substances which give H plus ions, and bases are the substances which gives OH minus ion. So basically what we can relate, that some substances like water, can donate, can what? Donate a proton, means acts as an acid. Can donate a proton, means acts as an acid in the presence of a base. So remember that it will act acid only when there will be a base in front of it, or you will be reacting it with base. So what we can relate, some substances like water can donate a proton, acts as an acid. Basically when it is donating a proton, it means what? That it is going to give H plus ion, but when in the presence of a base. So guys, if I say, in short form, that water is very adjusting in nature. Adjusting in nature, how? Like if suppose a base will come near to water, so a strong base will come near to water, so water will say, okay, no problem, I will act as a acid. If an acid will come near to water, so water will say, okay, no problem, I will act as a, yes, I will act as a base. So it can act like both depending upon what is coming near to it and how it is reacting. So it's as simple as that. So what we can understand, very simple, that water can act as an acid in the presence of a base, or accept a proton, or accept a proton means acts like a base in the presence of an acid. Okay, so it's very simple. So water is a weak electrolyte and undergoes self-ionization through a small extent. So first of all, water, it is a weak electrolyte and undergoes what? Undergoes self-ionization to a small extent. Very good. So we understood that whenever water is going to dissociate into ions, yes, what it is going to give? It is going to give H plus and OH minus ion. So let's just discuss about the dissociation constant and ionic product of water. Dissociation constant and ionic product of water. Dissociation constant and ionic product of water. Let's just discuss about it. Product of water. So what we can understand here, guys, a simple thing, that water whenever dissociates into ion, yes, water whenever dissociates into ion, we know that it gives H plus and OH minus ion. So if I have to write its dissociation constant, so I can write K is equal to concentration of products divided by concentration of reactants. Yes, can I write like this? Very good. So you know that water concentration is going to be constant. So I can write K into water concentration. I can write is equal to H plus ion concentration into OH minus ion concentration. And water concentration is going to be constant. So K into water concentration, can I consider as a separate dissociation constant as Kw? So K into water I consider as Kw, which is equal to H plus and OH minus ion concentration. So that's nothing but, this is Kw is a dissociation constant and it only gives us the ionic product of water, which is H plus ion into OH minus ion concentration. Very simple. Okay, everyone able to relate with it? It's very simple. Now talking about next thing, what we can write, yes, that Kw is equal to H plus ion concentration multiplied to OH minus ion concentration. So basically, how we can define it? The product of H plus and OH minus ion concentration. What we can relate, guys? The product of H plus and OH minus ions in water at particular what, guys? Concentration, or so at particular temperature is known as ionic product of water. Temperature is known as ionic product of water. Very good. So Kw is equal to H plus into OH minus ion. This is a main expression for us. But we should know many of the things more over here, not only this expression. So what we found is that Kw is a temperature dependent, first thing, because we said it is a, yes, at particular temperature. So what we can relate? Kw is temperature dependent. And how it depends, guys? It depends on the temperature. As the temperature increases, that Kw also increases. So that also we can relate that. So Kw is directly proportional to temperature. It means the value of Kw increases with increase in temperature. Very simple. The value of Kw increases with increase in temperature. Very good. Increases with increase in temperature. Good, guys. Now what we found, obviously we have to find it experimentally. So the value of Kw at 25 degrees Celsius, what we found, yes, that the value of Kw at 25 degrees Celsius, what it is found? It is found equal to 1 into 10 to the power minus 14 mole square per liter square. Mole square per liter square, because mole per liter is a unit for concentration. So when you will multiply H plus and OH minus and concentration, what you are going to get? You are going to get this unit only. Okay, so Kw at 25 degrees Celsius is equal to this, and you know that pure water is neutral in nature, so H plus ion concentration must be equal to OH minus ion concentration. So as we know, pure water is neutral in nature, it means what? Therefore H plus ion concentration should be equal to OH minus ion concentration, and which we can consider equal to X. Clear with it, guys? That in a pure water, so with the water, I just remember that I should drink little water. Okay, so as pure water is neutral in nature, what you can relate? Obviously it's neutral. Why? Because H plus and OH minus ion concentration is same, so that I can consider equal to X. Very good. So can I use this in the expression? I learned that Kw is equal to H plus into OH minus ion concentration, which we also found equal to 1 into 10 to the power minus 14 mole square per liter square. Very good. Now can I compare that? In this case, if this is there, I considered X. So X into X is equal to what? 10 to the 1 into 10 to the power minus 14. And what I will get? X square is equal to 1 into 10 to the power minus 14. And what will be X? Simple. X will be just the square root of 1 into 10 to the power minus 14. So 1 square root will be 1 only. 10 to the power minus 14, it is going to be 10 to the power minus 7. So X is 10 to the power minus 7, guys. 10 to the power minus 7, obviously mole per liter. Okay, this shows what? That at 25 degrees Celsius 1 liter, yes, what you can relate that? This shows that 25 degrees Celsius 1 liter contains only 10 to the power minus 7 moles of water in ionic form. So what we can relate? It shows that at 25 degrees Celsius, what we can interpret, in 1 liter only 10 to the power minus 7 moles of water is in ionic form, because it dissociates less, no, like self ionization is less, self dissociation is less, and that's what we can relate. Now remember that always, that if H plus ion concentration is equal to OH minus ion concentration, the solution will be what, guys? Yes, if H plus ion concentration is equal to OH minus ion concentration, what will be the solution? The solution is neutral. Correct, guys? Very good. If H plus ion concentration will be more than OH minus ion concentration, can you guys answer? What will be the nature of the solution? It will be acidic, basic, or neutral? Everyone should answer, guys. It's very simple. Yes, if H plus ion concentration is more than OH minus ion concentration, then the solution is acidic. Instead of neutral, you will mention that it is acidic. And if H plus ion concentration will be less than OH minus ion concentration, then the solution is basic. This is what you can relate. Very good. So if we have understood that the ionic product of water we have understood, and how we can relate that, so let's just understand an even small topic, which is nothing but what is the relationship between Ka and Kb. Let's just understand, because in our water there is Like it is acting as an acid also, it is acting as a base also. Okay, so I told you that water is a very adjustive and adaptable thing. Like suppose if water comes near to an acid which is a strong acid, so water will say what? No problem, if you're a strong acid, let me act as a weak base. So what will happen? Yes, the HCl will lose H plus ion and water will gain H plus ion. So you can relate that strong acid weak base. This is how it is going to work. But if you are taking a strong base plus adding water, so it is going to act as a weak acid, because now water is going to lose H plus ion and it will form ammonium ion plus OH minus ion. Clear with it, guys? This is very simple. Yes, very good. Now talking about the next thing, what we can relate, suppose if you have an acid or base which you are reacting with the water, how you can relate, what is the, yes, what will be the relationship between dissociation constant of an acid and base. Let's just discuss that. It's an important thing, small thing, important thing. Let's just quickly relate with it. Okay, so what we'll be learning, relationship between Ka and Kb. Relationship between Ka and Kb. So what is Ka and Kb over here? Ka is a dissociation constant of an acid and Kb is a dissociation constant of a base. Dissociation constant of acid and this is dissociation constant of base. Okay, very good. So how you can relate that? So if suppose you have an acid Ha, it reacts with the water. What is going to happen? Acid is going to lose H plus ion and water is going to act as a base. So what is going to happen? It is going to form a conjugate base here. So this is your acid. Acid will form a conjugate base. So if I write what will be the Ka for it, it will be hydronium ion concentration, A negative concentration, like water concentration we won't consider because it's going to be common, and here I'll get Ha. Same way, suppose if you are having this base A minus, now this reacts with water. So what is going to happen? It is going to accept H plus ion and water will lose H plus ion. Like that. Here water gained H plus ion, here water lost H plus ion. So can I write what will be the Kb? Kb will be Ha concentration, OH minus ion concentration and A minus concentration. Correct? Very good. So if you want to write the net reaction using reaction 1 and 2, the net reaction will be what? Tell me guys, what will be the net reaction? Yes? It's very simple. Net reaction will be 2 water molecules gives what? 2 water molecules give hydronium ion plus OH minus ion. So what you can do is you can write the K for it. How? So net reaction is this. So for the K, for this net reaction, because it is occurring in these 2 steps, so the K you can write will be equal to Ka into Kb, right? What you can do is that you can write K is equal to Ka into Kb. So this reaction is occurring in 2 steps. So what I can write? I can write K is equal to Ka into Kb, which is nothing but, yeah, Ka value if you will write, it was hydronium ion into A minus divided by Ha. And here Kb will be what? Ha into OH minus ion divided by A minus ion. So can I cancel these things? Yes. So what I'm left with? I'm left with hydronium ion, which is nothing but H plus ion concentration. Because remember that guys, your H plus ion concentration never remains just like that. Okay. So that you can relate. So H plus ion here and what you can relate over here into OH minus ion. So this will be, this K you should compare, it becomes equal to KW. what I can write is this is equal to Kw. So I can write Kw is equal to Ka into Kp. Yes, very good. So Kw is equal to Ka into Kp. Okay, let's just do few questions, guys. Let's just see who and all will be able to do it. Yeah. So the question is, calculate the concentration of H plus ion for calculate the concentration of H plus ion for water at 25 degrees Celsius. So it's very simple. Let me give you the options. A, 10 to the power minus 7 molar. B, 10 to the power minus 8 molar. C, 10 to the power minus 5 molar. D, 10 to the power minus 6 molar. So what will be the correct option, guys? Let's see who and all will be answering it. It's very simple. Yes. All of you should write it in the chat. Very good. Most of you are giving correct answer. Rest of the people also should give the answers, guys. Good. So the correct answer is what, guys? Correct answer is option A. If they are giving at 25 degrees Celsius, you know that the Kw value is K 10 to the power minus 14, and you will get H plus ion and OH minus ion concentration both in the same manner. But if I say, if the Kw of water at 35 degrees Celsius is found to be 10 to the power minus 12, calculate the concentration of OH minus ion if the concentration of H plus ion is 10 to the power minus 7 molar. All of you should try to do it, guys. It's very simple. I'm giving all of you a minute to try. It's just they have given you Kw at different values. So they have mentioned that what is it. And then the concentration of OH minus ion also, they are asking you to find it out. And they have given the concentration of H plus ion. So all of you should try to do it. Yes, everyone? Very good. All of you should solve it. Last 10 seconds. Those who have not given the answer, I want everyone to give the answer. Okay. So how we can do that, you know, Kw is equal to H plus ion concentration into OH minus ion concentration. Kw is given 10 to the power minus 12. H plus ion concentration is given 10 to the power minus 7. You have to calculate OH minus ion concentration. So OH minus ion concentration will be what? 10 to the power minus 12. Here it is in multiplication, so here it will come in division. Base same, sum, divide. So what you can do? Minus 12 minus 7. Minus 12 minus plus 7, you will get, how much you will be getting? 10 to the power minus 5 will be the OH minus ion concentration. Very good. Everyone clear with it? Let me give one more question as well. Question is, calculate the dissociation constant of base or dissociation constant of an acid if the Kb for base is given 10 to the power minus 3, 10 to the power minus 3 at 25 degrees Celsius. So if they doesn't mention also and they doesn't give Kw, so you have to consider that at 25 degrees Celsius only. It's very simple. You have to consider it at room temperature. Okay guys, so all of you should make sure that you're considering at room temperature. Now try to calculate. I'm giving you 1 minute. Yes, think how you can get the answer. It's very simple. Think the relationship, guys, what is there in between Ka and Kb. How if Ka is given to you, like Kb is given to you, how you can find it out Ka with what you can relate. So everyone tell me guys, it's very simple. So you can relate Kw is equal to Ka into Kb. This is the formula, no? So I hope now everyone can relate. At 25 degrees Celsius, that Kw is 10 to the power minus 14. Yes, Kw is 10 to the power minus 14. So which will be equal to Ka, I have to find it out, and Kb is given 10 to the power minus 3. So 10 to the power minus 14 divided by 10 to the power minus 3 is equal to Ka. So what you will get? You will get Ka is equal to 10 to the power minus 11. Clear with it guys? Yes. Very good. So this was a small topic, which is ionic product of water. Ionic product of water, what it helps us to give. So we know that water undergoes self-ionization and it gives very less ions like H plus and OH minus ion. And what you can relate, water has a beautiful property. It can be like, it can behave as an acid as well as base, depending upon, yes, depending upon what substance is coming and interacting with the water. So if an acid is coming and interacting with water, water is going to behave as a weak base. If a base is coming and interacting with water, then your water is going to behave as a weak acid. So this is what we can understand, and depending upon that, it's going to give the reaction. Then we understood the two major relationship, that Kw is equal to H plus ion concentration into OH minus ion concentration. Another is Kw is equal to Ka into Kb, which is very important. Okay, now if you want to learn about this chapter in detail guys, yes, what you should do, you should check out our classes, which is going on in our Unacademy platform. The way we have a classes here, so we have a 1 hour special classes which are absolutely free for everyone, which takes place on our Unacademy platform. So you can download Unacademy app and you can check those classes. In that we are doing the topics in detail. And also guys, yes, other than this, what you can relate, that here like on Unacademy platform we have a plus course classes in which we do the complete comprehensive coverage of syllabus. We do the complete comprehensive coverage of syllabus, and you guys can enroll for that also. For that you can use my code, which is MRIS10 for the registration, for getting the ongoing offers, and which is very good. Now if you liked this session and understood the topics, what you should do guys, you should subscribe our channel, you should like the video, and also yes, you should revise the topic again and again, and also should solve some questions related to it. It's really small topic, but it's an important topic. You can see the questions in many competitive exam and even in school exams too. So you can go through that. And yes, if you like the topic, you understood the topic, what you should do guys, yes, you should subscribe our channel, you should like the video, and also press the bell icon so that you will be getting all the notifications about the classes. So okay guys, happy Dussehra everyone. Yes, and we'll be meeting in the next session then. Thank you all of you. Bye bye.